Graphing quadratic functions in standard form. For any point on one side of the axis of symmetry, there is a point on the other side that is the mirror reflection of the first point. For this graph, 1, 6 and 5, 6 are symmetric points. 0, 11 and 6, 11 are also symmetric points. Such a pair of symmetric points corresponds to ordered pairs with equal y-coordinates. Both 1, 6 and 5, 6 have a y-coordinate of 6. 0, 11 and 6, 11 have a y-coordinate of 11. The only point that does not have a symmetric point is the vertex, which lies on the axis of symmetry. The vertex for this graph is 3, 2, and the axis of symmetry goes through the vertex. Method 1. Graphing by two symmetric points to find the vertex. To find the vertex of a parabola in which the ordered pair PS and the ordered pair QS are symmetric points, 1. Find the x-coordinate by using the formula x equals p plus q all divided by 2. In words, the x-coordinate is the average of the x-coordinates of any two symmetric points. 2. Find the y-coordinate by evaluating f at the value found in step 1. That is, find f parentheses p plus q all divided by 2. In this example, find the x-coordinate of the vertex of the parabola sketched in the indicated figure. So for this parabola, we have the ordered pair -7, -11, and the ordered pair 2, -11. What we're looking for is the x-coordinate of the vertex. Our first step is to take the x-coordinate of our symmetric points, -7, and add that to the x-coordinate of the symmetric point, which is 2, and divide them both by 2. So I need to find -7 plus 2 first, which is -5, then divide that answer by 2, and that gives us -2.5. So the x-coordinate of our vertex is -2.5. Find the x-coordinate of the vertex of a parabola that passes through the given points 0, 5 and 8, 5. So we want to find the average of the x-coordinates of the 2 points. 0 plus 8 divided by 2, which gives me 8 over 2, which reduces to 4. So 4 is the x-coordinate of our vertex. Using symmetric points to graph a quadratic function in standard form, method 1. To sketch a graph of a quadratic function, f of x equals ax squared plus bx plus c equals 0, where b does not equal 0, 1. Find the y-intercept. 2. Find the y-intercept's symmetric point. 3. Average the x-coordinates of the two symmetric points to find the x-coordinate of the vertex. 4. Find the y-coordinate of the vertex. 5. Depending on how accurate your sketch is to be, find additional points on the parabola as needed. 6. Sketch a parabola that contains the points found. In this example, graph the function by hand. Find the vertex. Y equals x squared minus 4x plus 5. For our first step, we want to find our y-intercept. For our y-intercept, x will equal 0. Substituting, I get y equals 0 squared minus 4 times 0 plus 5, which leaves me with y equals 5. My first order pair for my parabola is going to be 0, 5. Step 2, I want to find the point that is symmetric to my y-intercept. If it's symmetric, that means they both have the same value for y. Since my y-intercept was 5, I can substitute 5 into my original equation. I get 5 equals x squared minus 4x plus 5. Solving for x, I subtract 5 from both sides. 0 equals x squared minus 4x. Factoring out my x, 0 equals x parentheses x minus 4. Using my zero factor property, x equals 0 or x minus 4 equals 0. Solving x minus 4 equals 0, I add 4 to both sides and x equals 4. I've already used my x equals 0 as a part of my y-intercept, so my second order pair is 4, 5. So now I have a set of symmetric points. Now we're ready for step 3, where we average the x-coordinates of our symmetric points. 0 plus 4 divided by 2 equals 4 over 2, which is 2. Step 4, we want to find the y-coordinate that goes with 2, substituting y equals 2 squared minus 4 times 2 plus 5. 2 squared is 4, minus 4 times 2 is 8, plus 5, which gives us 1. So our vertex is 2, 1. Now that we have our 3 points, we are ready to plot on our graph. So we have 0, 5, 4, 5, and 2, 1. Graphing our parabola, we now have the graph of y equals x squared minus 4x plus 5. In this example, graph the function by hand, find the vertex. Y equals negative 2x squared minus 8x minus 3. The first step is to find our y-intercept, which means x is going to equal 0. Y equals negative 2 times 0 squared minus 8 times 0 minus 3. Y equals negative 3. So our first order pair is 0, negative 3. Step 2 is to find the y-intercept symmetric point. Substituting negative 3 into our original equation, negative 3 equals negative 2x squared minus 8x minus 3. Adding 3 to both sides, 0 equals negative 2x squared minus 8x. The greatest common factor is going to be negative 2x, so 0 equals negative 2x parentheses x plus 4. Setting each of them equal to 0, negative 2x squared equals 0. Dividing both sides by negative 2, x equals 0, which is our y-intercept. X plus 4 equals 0. Subtracting 4 from both sides, x equals negative 4. So our second order pair is negative 4, negative 3. Step 3, we want to average the x-coordinates of our symmetric points. 0 plus a negative 4 divided by 2 equals negative 4 divided by 2, which is negative 2. Step 4, I want to find the y-coordinate for my vertex. Substituting for x, y equals negative 2 times negative 2 squared minus 8 times negative 2 minus 3. So y equals negative 2 squared is 4. 4 times negative 2 is negative 8. Minus 8 times negative 2 is a positive 16 minus 3, which equals 5. So my last order pair is negative 2, 5. Plotting our points, I have 0, negative 3, negative 4, negative 3, and negative 2, 5, with negative 2, 5 being the vertex. Graphing my parabola, I now have the graph of the function y equals negative 2x squared minus 8x minus 3. Method 2. Graphing by using the vertex formula to find the vertex. To find the vertex of the graph of a quadratic function f of x equals ax squared plus bx plus c, 1. Find the x-coordinate of the vertex by using the vertex formula x equals negative b over 2a. 2. Find the y-coordinate of the vertex by evaluating f at the value found in step 1. That is, find f of negative b divided by 2a. In this example, a parabola has the given x-intercepts. What is the x-coordinate of the vertex? Again, we're going to find the average of our two x values. Negative 4 plus 3 divided by 2 equals negative 1 divided by 2, so negative 1/2 or a negative 0.5. In this example, find the x-intercepts and the y-intercepts. Find the x-intercepts and the y-intercept. Find the vertex. Then graph the function by hand. So the first thing we need to do is find our x-intercepts, which means our y, or in this case f of x, is going to equal 0. 0 equals x squared minus 4x minus 5. I need two numbers that multiply to be a negative 5 and add to be a negative 4. So 0 equals, in one parentheses, x minus 5, in the other parentheses, x plus 1. Setting each equal to 0, x minus 5 equals 0, which means x is 5. Or I can set x plus 1 equal to 0, which means x is negative 1. So my x-intercepts are 5, 0, and negative 1, 0. So now we want to find our y-intercept, which means x is 0, f of 0 equals 0 squared minus 4 times 0 minus 5. So f of 0 equals negative 5. So we have our y-intercept 0, negative 5. Our next step is to find the vertex. To find the vertex, we need to remember that the standard form of parabola is y equals ax squared plus bx plus c, and we can find the x-coordinate of the parabola using x equals negative b divided by 2a. X equals negative, my b is negative 4 divided by 2 times a, which is 1. So bring over the negative. Negative 4 divided by 2 times 1 is a negative 2, and the opposite of negative 2 is 2. To find the y-coordinate, I want to find f of 2, which equals 2 squared minus 4 times 2 minus 5. 2 squared is 4, minus 4 times 2 is 8, minus 5 equals negative 9. So my vertex is 2, negative 9. Now that I have these points, I can plot them on our graph. 5, 0, negative 1, 0, 0, negative 5, and 2, negative 9. Then I can draw my parabola. So this is the graph of the function f of x equals x squared minus 4x minus 5. In this example, find the x-intercepts and the y-intercept. Find the vertex. then graph the function by hand. F of x equals x squared minus 10x plus 16. Our first step is to find our x-intercepts, which means y is 0. So 0 equals x squared minus 10x plus 16. I need two numbers that multiply to be 16 but add to be a negative 10. So I have x minus 8 and x minus 2. Using the zero factor property, x minus 8 equals 0, which means x equals 8, or x minus 2 equals 0, which means x equals 2. So my x-intercepts will be 8, 0, and 2, 0. Next, I want to find my y-intercept, which means x will equal 0. So f of 0 equals 0 squared minus 10 times 0 plus 16. So f of 0 is 16. That means our y-intercept is 0, 16. So to find the vertex, we want to begin with our x-coordinate. X equals the opposite of b, which in this case is negative 10, divided by 2 times a, which is 1. Negative 10 divided by 2 times 1. I bring over my negative. Negative 10 divided by 2 times 1 is negative 5, which means the x-coordinate of our vertex is 5. Substituting that into our function, f of 5 equals 5 squared minus 10 times 5 plus 16. 5 squared is 25 minus 10 times 5 is 50 plus 16, which equals negative 9. So our vertex is 5, negative 9. Now we want to plot our points. 8, 0, 2, 0, 0, 16 is a little too big for our graph, and then 5, negative 9. Then draw our parabola through our points. And now we have a graph of the function f of x equals x squared minus 10x minus 16. Minimum or maximum value of a function. For a quadratic function, f of x equals ax squared plus bx plus c, whose graph has a vertex hk. If a is less than 0, then the parabola opens downward and the maximum value of the function is k. So anytime your a is negative, your parabola will open downward. If a is greater than 0, then the parabola opens upward and the minimum value of the function is k. That means if a is positive, our parabola will open upward. In this example, a batter hits a baseball. The ball's height in feet h of t after t seconds is given by h of t equals negative 16t squared plus 140t plus 3. A. What is the ball's height when the batter makes contact with it? B. What is the maximum height of the ball? When does it reach that height? When the batter hits the ball is going to go up, then gravity kicks in and it comes back down. So I'm going to have a parabola that opens downward. I also know that it's going to open downward because my A is a negative 16. So for part A, I need to find the ball's height when the batter makes contact with it. When the bat hits the ball, that is going to be when time is 0. And then the ball starts to curve upward, then downward. So we're looking for h of 0, which equals negative 16 times 0 squared plus 140 times 0 plus 3. Since everything else is 0, h of 0 is 3. What is the ball's height when the batter makes contact with it? 3 feet. Now we want to find the maximum height of the ball. In order to do that, we need to know the vertex. X equals negative parentheses b over 2a. So x equals the opposite of, my b is 140, divided by 2 times a, which is negative 16. So I have negative 140 divided by a negative 32, which gives us 4.375. My negatives cancel each other out. So what we have found is our time. That's when it reaches the maximum height. Now what we need to do is figure out what that height is. So h of 4.375 equals negative 16 times 4.375 squared plus 140 times 4.375 plus 3. So we want to calculate this. So we start by typing in negative 16 parenthesis 4.375 close parenthesis square plus 140 times 4.375 plus 3. Enter. We get 309.25. So for part B, the maximum height of our ball is 309.25 feet. And when does it reach that height? In 4.375 seconds. Graphing quadratic functions in standard form. Standard form for a parabola is y equals ax squared plus bx plus c. Graphing by using two symmetric points to find the vertex. You find your two symmetric points by looking at the 2 points that have the same value for y. Then you take the two values for x, add them up, divide that answer by 2, and that gives you the x-coordinate of your vertex. To find the y-coordinate, substitute back into the function of the parabola and solve for y. Graphing using the vertex formula to find the vertex. The vertex formula is x equals negative b divided by 2 times a. Once you find that value for x, you substitute back into the function and solve for y. The minimum value of a function occurs when you have a positive a and your graph opens upward. The maximum value of a function occurs when you have a negative a and your parabola opens downward.